Hi everyone, welcome back. So in this video, we are going to continue demonstrating the different packet tracer activities of module 11. So here we are going to work with the opportunity of applying VLSM technique for subnetting of IPv4 addresses. So in this video, I'm going to demonstrate the packet tracer activity 11.9.3, where we have an example IPv4 network, and we are given a scenario where we need to apply variable length subnet mask scheme to make sure the subnet is designed according to the requirements. So let's get going. So this is how the topology looks like. If you see here, there are two routers and we have four switches which are connected, and we have four PCs. So let me also check out what the activity question says. So it says you might receive, there are three possible topologies which you might get. And once again, the addressing table is completely empty. We have to fill this addressing table. And there are three objectives given. The first objective is you have to examine the network requirements. Then you have to design the VLSM addressing scheme, and then you have to assign the IP addresses to the devices and then verify the connectivity. Okay, in this activity, you are given a 24 network address to use and design a VLSM addressing scheme. Based on the set of requirements, you will assign subnets and addressing, configure devices and verify connectivity. Okay, that's what we are going to do here. So instructions in part 1, it is saying that examine the network requirements. So determine the number of subnets needed. So if you check out this topology again, what you can see here is clearly, this is one particular subnet. This is the second subnet, SW4. The third subnet is SW1. The fourth subnet is SW2. And again, you have a connectivity between the two routers. So altogether, we need 5 subnets to implement for this topology. Okay. And this is the address that you're given, 192.168.72.0/24. So as soon as you see the /24 notation, you should keep in mind that the first 3 octets are fixed. The first 3 octets are fixed. You are not going to touch them. Only we will be able to play with the last 8 bits of this host portion. So we'll see what it is. The network has the following requirements. Okay. It is saying that one LAN requires 7 hosts. SW2 LAN requires 15 hosts, SW3 LAN requires 29 hosts, and SW4 LAN requires 58 hosts. Okay, we already answered this question. How many subnets are needed? 5. So we are actually being given 4 subnets here, but for the 5th subnet, which is nothing, you are actually given the requirements for these 4 switches, these LANs, SW1 LAN, SW2 LAN, SW3 LAN, and SW4 LAN. But the 5th subnet is the connection between the remote site 1 and remote site 2. So for that, we need only 2 hosts. So make sure that whenever you do the subnetting, you have to take into consideration that we require 5 subnets and the 5th subnet will require 2 hosts. Determine the subnet mask information for each subnet, which subnet mask will accommodate the number of IP addresses required for SW1. We'll work on these things. Okay. And it is also saying that once you take this address and you decide the subnet mask that we are going to use for each and every one of the requirements specified for each LAN, and then we have to fill this table. This table is called the subnet description. So how do you get the subnet description? It is saying that use the first subnet to accommodate the largest LAN. Here, the largest LAN required is SW4 LAN. So the subnet which we are going to create, which can accommodate up to 58 hosts, will be assigned to SW4. Similarly, second subnet to accommodate second largest LAN. It is a kind of rule where you apply VLSM. What we usually do is we tend to start from the first, or we tend to assign the first subnet to the LAN which requires the highest number of hosts. So similarly, we go in the decreasing order. So 58. The second subnet will be assigned to 29, or that is SW3 LAN. The third subnet will be assigned to SW2 LAN, or which requires 15 hosts. And the fourth subnet will be assigned to SW1 LAN, which requires 7 hosts. And finally, another subnet will be assigned to the connectivity between them, which is the WAN connectivity, and which has only 2 hosts. So let me show you how I design this scheme. I have a paint here. I'm going to just demonstrate here. Hopefully everybody understands this. Okay, so let me show you that. Give me 1 second. So this is what our address is. This is my address which is given, 192.168.72.0/24. And once again, I iterate that once I see the /24 notation, you must understand that the first 3 bits here are the first 3 octets in this particular address are fixed. You are not going to change anything out of that. But we require 5 subnets, and the last octet, which is 8 bits, we can actually work with. So this is my requirement, which I say we have we require 5 subnets, and these are the requirements of each subnet. But as per the requirements given, the first subnet is to be assigned to the LAN which requires the 58 hosts. Now, what I'm going to do here is I'm going to take these bit positions which I just have written down here, and we are going to work in such a way that we will find out what the requirements are and how do you get to the network and host portion in these 2 bits. So, first requirement is 58. Okay, the first requirement for us is 58. So in order to get 58 hosts, how many bits we require? 2 power 5 gives me 32, which is not sufficient. 2 power 6 gives me 64. Out of the 64, 2 addresses go. So the usable number of hosts, if I take 6 bits from the host portion, if I take it, is 62, which is sufficient for this. So for the first subnet, my subnet mask is going to be /26. So how did I get this /26? Because I am going to keep these 2 bits for the network portion and leave the remaining bits for the host portion. Okay, so let me do that. So because it's the very first subnet, I can put all zeros in here. So I can put a 0 here, 0, 0, 0, 0, 0, 0. So which makes this as the first 3 octets is the same. So I'm not writing them. This is .0/26. Okay. Now, what will be the last address in this particular subnet? For the last address, what we usually do is we put ones in the host portion. Okay. So which gives me how much? Which gives me, so 32 plus 16, 48, 56, 60, 62, 63. So I have .63/26. So this is my first subnet. This is the network address. This is the broadcast address. And here the usable host address or in other words, the first host address that I can use is .1/26. The last host address that I can use here is .62/26. So this is my subnet 1. I'm done. So let me move on to the next subnet. Okay, let me move on to the next subnet. So for my next subnet, I require 29 hosts. I require 29 hosts. So in this 29 hosts, how many bits do I require? If you take 2 power 5, 32 bits. So if I get 32 minus 2, 30. So this is good. So if I get 5 bits in my host portion, how many bits go for my network portion? 3 bits. So 24, which is already there, plus 3 bits of my network portion gives me a subnet mask of /27. Okay. So here, what we are going to do is, here we are going to go the first 3 bits into your network portion. Okay, so this is done here. So I'm writing down once again for my network portion. What I'm going to do is already 32 is kept here, and we already use the address of 63. So the next address in this particular hierarchy is .64. So I place a 0, 1, 0, and all zeros in my network portion. Sorry, in my host portion, which gives me the network address as .64/27. This is the subnet mask for this /27. So for my broadcast address, what will I get is 0, 1, 0, 1, 1, 1, 1, 1, which takes how much? So 64 plus 16, 80, 88, 92, 94, 95. So my last or my broadcast address for my second subnet will be this. And for this subnet, which is my subnet 2, the first host address that I can use is .65/27, and the last address that I can use is .94/27. So this is my subnet 2. So this is also done. Now let me go for the next one, which is the next requirement for me is 15. So for 15, how many bits I require? You might think straight away as 4 bits, but usually most people make this mistake. If I take 4 bits, the maximum number of hosts that I can get is 2 power 4 minus 2, which is 14. So 4 bits isn't sufficient in order to support 15 hosts. I need to go for 5 bits again. So if I take 5 bits, obviously my subnet mask will be the same as above, because I have taken 5 bits in the earlier thing also. So we are going to keep the same subnet mask here. We are going to keep the same subnet mask here. And once again, the last address portion, the last address that we used for my earliest subnet is 95. So the next address will start from 96. 0, 0, 1, 1. And let me put all zeros in the host portion, which gives .96/27. The subnet mask did not change because we are using the same number of bits for my host part. Okay, so 0, 1, 1 and 1, 1, 1, 1, 1, which gives how much? 96 plus 16 gives me 112, 120, 124, 126 and 127. So .127/27. This is my third subnet. This is my third subnet, and the first host address that I can use here is .97, and the last address that I can use here is .126/27. Now this is done. The subnet 3 is done. So let me move on to the next subnet, which has a requirement of 7. So in order to support 7 hosts, how many bits I require? Not 3 bits, because 2 cube is 8, and 8 minus 2 can give me only 6 hosts. So in order to support 7 hosts, I need to take 4 bits. Now if I take 4 bits, so in the host portion, how many bits will be left for the network portion? 4 bits. So my subnet mask will become 24 plus 4. 24 plus 4 gives me 28. So let me do this. Now I'm having 4 bits for my network portion and 4 bits for my host portion. So here the last address that we have taken is .127. So the next thing is 128. So I'm putting 1 here, 0, 0, 0, 0, 0, 0, 0, which gives .128. What is the value? /28. What will be the last address or the broadcast address in this subnet? 0, 1, 1, 1, 1, which is equal to how much? 8 plus 4, 12, 14, 15. So 15 plus 128 gives me 143/28. So this is my subnet 4, and here once again the first usable address will be .129 and the last usable address will be 142, but the subnet mask is /28. So I am done with my 4 subnets. But remember, here we require 5 subnets. Okay, so the next thing which I have to do is I have to create a subnet to support 2 hosts. So to support these 2 hosts, how many bits do I require? 2 bits. 2 square minus 2. So now my subnet mask will become /30. Because if I'm only going to keep 2 bits for host portion, the remaining number of bits are 24 plus 6 gives me 30 here, subnet mask. So let me come back here for the 5th subnet. This is what I do. Now I already used 142 here, 143. So the next thing is 144. So 128, 0, 0 1 0 0 0 0, which gives me the address of dot 144/30. Once again, for the last address, what we will get is 100100011 to get the broadcast address for this network, which will be dot 147/30. So this is my subnet number 5 according to my requirement. Subnet number 5, and the first usable address will be 145. The last usable address will be 146. So I applied the VLSM scheme and I divided the network address which I have here, and I actually got this is the network address that I have, and I divided this network address according to my requirements, the number of subnets and number of hosts per subnet, and I got these things. Now let me put all these values into a tabular format, and this tabular format we can use for our address assignments. So this is what we have. If you see, we show slowly. Now this is what it is given. So this is the number of subnets we have. This is what, and it is saying that use the first subnet to accommodate the largest LAN. That's what we did. We started with the subnet SW4 LAN, which requires 58 hosts, and then we moved on. So first subnet, second subnet, third subnet, fourth subnet, and the last subnet is actually given for the connection between the remote site 1 and remote site 2. So this is what we got. Whatever I have written down here, it is the same thing that this is the same thing that we have here. Yes, this is the same thing that whatever I have written in the paint. So this is how I made the calculations, and this is how we put it in your Word format. So in order to have a clearer look, if you see the LAN first 021 72.0 to 26, 27, 27, 28, and 30. These are the same subnet mask that we used. And once again, the first usable address is written down here, the last usable address is written down here, and the broadcast address is written down here. So once you write all those things into the tabular format, we have to assign the addresses accordingly. If you see here, the entire addressing table is empty. Now, in order to assign these things, how they gave it? Just check these things. Assign the first usable IP address to remote site 1 for the 2 LAN links and the WAN link. So if you come here, it will be easy for me to show into here. Now, first usable address to remote site 1 for the 2 LAN links and the WAN link. So if you take the first interface Z0 by 0, if you see, the first usable IP address is 129, user 1 LAN. Okay. And then we go for the next one is 97 here, which is the user 2 LAN. Sir, how did you assign user 1 LAN and user 2 LAN to remote sites, these two interfaces? If you check it out here, see, the remote site 1 interface here goes to, if you can see, this is the interface address also is given here. It goes to SW1, which is 7 hosts, which we assigned the subnet 4. And this goes to SW2. If you go here, there you go. This is 0 by 1, 0 by 1. See here, this goes to SW2, which goes to user 2, which requires 15 hosts, which is our subnet 3. And for this, we have the serial interface, S0 by 0 by 0. So using this terminology, what I did was I assigned them appropriately. So I have taken the last LAN, which is the fourth LAN that we did, 129, the first address I assigned 129. And if you please remember, you have to put the appropriate subnet masks, because each LAN has got a different subnet mask here. It's 28. So I gave 240. It's 28, I gave 240. And because it's 27, we gave 224. And because it's 30, I have given 252. So the subnet mask will tell you, or it will clearly identify which is the network portion, how many bits are there in the network portion. If we don't give the appropriate subnet mask, this entire thing won't work. Similarly, we assign the first usable IP address to remote site 2 for the 2 LAN links. If you go to the topology again, you can see that for remote site 2, The first connectivity is for SW3, which has got 29 hosts, which is our subnet 2. And the second connectivity is G0 by 1, which goes to SW4, which contains 58 hosts. Okay, Z0 by 0, Z0 by 1. Okay, so if you come back here, the address assignment shows that for remote site 2, we have did the same thing. The first LAN, which supports the 58 hosts, is connected to Z0 by 1 of remote site 2. I gave the same address. And once again, if you see, the subnet mask is variable. It's not the same. Earlier, we used to have the same subnet mask for all the different subnets that we created, but it's different here. And we also have to set up the default gateways. By now, we must have understood the concept of default gateways. If you see here, for user 1 and user 2, SW1 and SW2, the default gateways are nothing but the IP addresses that we assign for these interfaces, Z0 by 1 interface and Z0 by 0 interface here. Similarly, for user 3, user 4, and SW3 and SW4, the default gateway addresses will be the IP addresses of the appropriate interfaces. For SW3, it will be the IP address given to G0 by 0 interface of remote site 2. For SW4 and user 4, it will be the address given to Z0 by 1 interface of remote site 2. Okay, so this is how you write them down. If you as an example, you can see here SW4, the default gateway address is 192.168.72.1, which is nothing but the interface address of G0 by 1 given for remote site 2. The same for this, assign the second usable IP addresses to the switches. That's what. So you know the switches are connected to which LANs, and accordingly we will give these things. And then assign the last usable IP address to the host. So this is what we do. So these are the 4 hosts that we have, and these are the 4 hosts that we did. Okay. So let me show you how the IP address assignment now goes. We filled up all the tables. We made all the assignments. It's all done right now. And let me show you how to go with the configurations. So it is asking assign IP addresses to devices and verify connectivity. Okay. It's asking me configure IP addressing on the remote site 1 router interfaces. Okay. What are the router 1 interfaces that I have here? If I go here, router 1 interfaces. So G0 by 0, I have to write these things. Okay. Let me go here. Go to router. Let me go to router. There you go, router 1, and let me enter. So enable configure terminal and interface Z0 by 0. Enter. So let me just make it much more clearer. This is the IP address that I have. Okay, fine. Let me go here. IP address. As I told you, in order to not make many typing mistakes, I tend to do the copy paste thing from my tables. I usually prepare these tables, or during exam, if you are not getting an opportunity to open any other windows, write them on a piece of paper. You have to work with this on piece of paper, which will make it much more easier. Enter, and no shutdown. Okay, so that is one interface that I have given, and it asked me to clear both the interfaces. So let me do for the Z0 by 1 interface also. There you go. This is the interface that I have, and 97. So once again, let me do this IP address. This will become how much? 224, and this becomes 97. Enter. No shutdown. Okay, no shutdown. That's it, done. And let me go to the topology ones. Do I need to assign this? This is already assigned, I think, but this is already assigned. It is asking me to remote site run router LAN interfaces, so I did both of them. It is also asking me configure IP addressing on SW3 switch, including the default gateway. Okay, so what is the switch I gave? SW3 I have 72.66. okay, let me go to switch 3 here. This is done because it only asked me to configure the LAN interfaces. And a small clue is, if you don't configure them properly, you don't see the green colored ones here. You will see a red colored one. So let me go to switch 3. Let me go. The CLI tab is already up and running. Very good. So enable configure terminal. Once again, we have to go for switch interface VLAN 1, which is the default SVI. Then I have to IP address of switch, paste, space how much for the switch? 66, and then this is the subnet mask. Enter 66. Enter. No shutdown. Enter. And don't forget, you have to give the IP. This I can IP no, default gateway. What is IP default gateway for switch 3? This is the one for default gateway for switch 3, which is nothing but the router IP address of the router interface that is connected. So enter. I have given the switch. Is there anything else that I need to configure? Did they give me anything? Please check it up. So I did the IP addressing on the switch 3, including the default gateway. I gave those things. Now it is asking me configure IP addressing on user 4, including the default gateway. Okay. So let me go to my table again. This is the good thing, that if you have a table ready with you, you can simply check it out these things and directly copy paste them here. Let me go to the user 4. This is in this particular LAN. For this user 4, I need to go to IP configuration, IP address I assigned according to the table. This is my subnet mask here. So let me go here again and let me give the IP address mask, and the default gateway here is this. So let me check it out. Here you go. I gave all the requirements that it asked of me. Close it. So let me see if I'm done. Yes, excellent. I got the 100% down here. It's all done. But just to be on the safe side, let me verify the connectivity. So let me see if I'm able to ping let me try from user 4. Let me try from user 4. It's already open. Let me try pinging user 3. So user 3's IP address is this. Oh, let me paste it. Some of these configurations are already done internally, so you need not bother much. Let me go to command prompt, ping, and then press paste, enter. So I'm going to try only one ping here. Timed out. Yes, it's working. So most of it is working now. So this is how you actually do the VLSM. Okay, so let me show you the other two topologies also, and then you can have an idea what to expect in the exam. You might get different topologies. So let me show you the other topologies that you might get. This is the second topology that you might receive, which is 172.31.103.0/24. And these are the different requirements for the subnets that you might need to design, which there are, once again, you need to design 5 subnets, and the subnets have requirements respectively as 27 hosts, 25 hosts, 14 hosts, 8 hosts, and finally the 2 hosts. So as I said, the very first subnet is designed in order to accommodate the largest LAN. In order to accommodate 27 hosts, you need at least 5 bits. If you say, if I say as 27 hosts, the number of bits that you might require is 2 power 5, 32 minus 2, 30. So if I take 5 bits, if I keep 5 bits as host bits, the remaining bits go into the network portion. So now my subnet mask will become 24 plus 3 gives me 27. Let me see how you get it here. So if it here, these 3 bits will be now into the network portion, right? So let us, because this is the very first subnet, let me put all zeros in here. So it's a 0, 0, 0, 0, 0, 0, 0, 0. This makes the address as .0/27. Now, for the broadcast address of this network, let me put all ones in the host portion, which gives me 16 plus 8, 24, 28, 30, 31. So which equals to .31. This is the broadcast address, 27. So this is my subnet 1. This is my subnet 1, in which the first usable address will be .1/27, and the last address will be .30/27. So let me go to the next one. So for my next requirement, I have 25 hosts. Basically, even for 25 hosts, I need to take 5 bits. So if I keep 5 bits for my host portion, the remaining bits go for my network portion. So my subnet mask will be 3 bits of network portion plus 24 gives me 27. So we have to continue the same subnet mask. And here the last address is 31. So I go for 32. 0, 0, 1000000, which gives the network address for my second subnet as 32/27. The broadcast address will be 001, the last address. That means 111. Put all ones into the host portion, which you get as 32 plus 16, 48, 56, 60, 62, 63. So dot 63/27. So this is my subnet 2, where the first address will be dot 33 and the last address will be dot 63/27. So the subnet mask remains the same. So for if I go on to my next requirement, which is 14, for 14, how many bits do I require? If I take 4 bits, 2 power 4, 16 minus 2, which gives me 14 bits. So if I keep 4 bits for my host portion, then my subnet mask will become 28, because there are these 4 bits are taken for my host portion and added to the network portion. So let me draw that. And now I have 4 bits as part of my network portion. I already kept dot 63 here. So my next option will be 0, 1, 0, 0, 0, 0, 0, 0, which gives me dot 64/28. And for the broadcast address, it will be 64 plus 8, 72, 76, 78, 79. So the broadcast address for this subnet will be /28. So this is my subnet 3, where my first usable address will be 65. The last usable address will be 79. Once again, the subnet mask here we have to specify as 28. The next is once again 8 hosts. So if you remember correctly, 3 bits are not sufficient. Even for 8, what we need to do is we need to take 4 bits. So once again, the portion will be 28. Okay. So for these 4 bits, once again, I'm drawing the same thing here. So let me continue. So here we kept dot 79. So the next option will be 80. So 0, 1, 0, 1, all zeros. So the network portion will be, the network address will be dot 80/28. And for this it will be 0, 1, 0, 1, 1, 1, 1, 1, which equals to 80, 88, 92, 93, 92, 94, 95, which equals to 95/28. This is my fourth subnet, subnet 4, which I am going to use. Okay, and here once again my first usable address will be dot 81/28, and the last address will be dot 94/28, because the first 3 octets are common here. So the first 3 octets here are common here. You don't have any change here. Okay, so let me go for the last subnet, which we are going to write down. Okay, so the last subnet here is, the number of requirements is 2 now. Okay, now the requirement is 2. So what we can have here is, for 2 hosts, I need to try at least 2 bits. So my subnet mask will be /30. Now here, this is where we get. Okay, and because we already gave 95 here, the next obvious choice will be 96. So 0, 1, 1, 0, 0, 0, 0, 0, which gives me dot 96/30. For the broadcast address part, you just place ones here, which gives me dot 96 plus the 99. So we have our subnet 5, which can be assigned between the link which is the subnet 5. The usable addresses are .97 and .98, but please remember that you have, this is the subnet mask of 30. Now for this, once again, I will show you the Word document. So this is what we are just did. This is what we got: 27, 27, 28, 28, 30. And once again, based on the scheme that is actually given in your question sheet, you have to make sure that the address assignment is done properly. So this is how you actually divide it. There is one more scenario, which let me show you that scenario also, then we will stop this. This is the third topology that you might get, which says 10.11.48.0/24, and these are the different requirements. So let me start with the first requirement, which is 60 host. So for 60 hosts, we require at least 6 bits. So my subnet mask will become, if I keep 6 out of 8, there are 2 remaining which goes into the network portion. Now these 2 and the 24, which is already given, which makes the subnet mask as 26. So if I come here, if I keep these 2 bits as my network portion bits, let me put all zeros because this is the very first subnet. Let me put all zeros in here, which gives me .0/26. And for the broadcast address part, what I would get is this is equal to .63/26. So this is my first subnet, and for here the first usable host address will be .1/26 and the last usable host address will be .62/26. Okay, so let me go to the next one. So this is the requirement I just did. For the 30 requirement, if you remember, 2 power 5 gives me 32. So 2 power 5 minus 2, 30, which is equivalent. So if I keep 5 bits for my host addresses, 3 bits goes into my network portion. So the subnet mask will become /27. So here the next, here now the 3 bits go into the network portion, and we have 63 here. So 0, 1, 0, 0, 0, 0, 0, 0, which gives me .64/27. And if I place all ones in here, I get the next address as .95/27. So 64 plus 16, 80, 88, 92, 94, 95. So this is my second subnet, and this is my second subnet, and my first usable host address is .65, and the last usable host address is .94/27. This should not be forgotten. Okay, it should not be forgotten. It's very important that you don't mess up these things. So for the next part, which is 14, for 14, once again I can go for 2 power 4, 16, 16 minus 2, 14. This is sufficient. So if I take 4 bits out of my host portion, now I get the subnet mask as /28. So .95 is used. Now the next appropriate address will be .96. So here, now I am going to use the subnet mask as 28. I have 4 bits into my network and 4 bits into my host. So 0, 1, 1, 0, 0, 0, 0, 0, which gives me .96/28. And for ones, okay, 96, 8, 104, 108, 110, 111. So which I will get as the last address is 111/28. So this is my third subnet, and the first usable IP address here is .97. The last usable IP address will be 110/28. This you have to keep in mind. And after that, let me take on the next one, which is 6. So for 6 hosts, we require how many bits? 3 bits. So the subnet mask will become how much? 26 plus how many? 6 plus, for 3 bits is 8. So 24 plus 5 gives me 29. If I come back here, this is what the last 3 bits will be kept for my host portion. And if I take this correctly, the next address should be 112, that is 0. Sorry, this must be 0 here. 64 plus 32, 96. 96 plus 16, 112. 0, 0, 0, 0, which is equal to dot 112 slash 29. Okay, and for the broadcast address, just put it down here. What you get is 112 plus 116, 117, 116, 118, and 119. If we see here, the broadcast address will be 119 slash 29. So this is my fourth subnet, where the first usable IP address will be 113 and the last usable IP address will be 118 slash 29. So we come to the last part where we require two hosts. So for two hosts, I require only 2 bits. So my IP, my subnet mask will be slash 30. So here it comes this part. So I have already kept 119. So my next portion is 120. So 0, 62 plus 32, 96, 112, 120, 0, 0, 0 is equal to dot 120 slash 30. Here I'll have only 2 bits in the host portion, which is equal to dot 123 slash 30. So this is my fifth subnet. This is my fifth subnet, and my usable IP addresses will be dot 121 and dot 122 slash 30. So if you take the Word document, you can see the same here. This is what we just did. And based on the addressing schemes, you have to assign these subnets to the appropriate lands. You can't simply just assign whatever you want. You have to do it according to the requirements which is stated in your question sheet. Okay. So I hope everybody understood this. And please practice this on your own. First, do the calculations properly. And if you do, once you do the calculations properly, the address assignment to the data devices will not take a lot of time. So thank you very much, and I hope everything's okay. Thank you.